we didn't really know where we were going to go in this world, but we've done just about everything that you can possibly imagine. And, lately I've heard a lot of people giving me a lot of talk about, aviation's hurting, it's on decline, we're not seeing as much activity, everything's kind of, not all that great in the aviation community. But I got to tell you, I'm at a spot right now where I have never been more optimistic about aviation than I am right today. And one of the reasons for that is all about this electric propulsion and electric flying that we're going to be doing in the future. And, I've been doing this so long that, you get to the point where you think, what else am I going to do at this point? And this picture that I've got up on the screen coming up next here is a picture of me when I first hopped in this airplane with electric power plant on the thing. And I can tell you, I've never been more happy doing aviation than the day I was sitting behind this airplane and that little electric motor was whirling away and cruising me through the sky. And so it got me thinking about this whole process about where we're going with the world. And I believe we're really on the cusp of a change in aviation that is the same kind of paradigm shift that we had during the jet age. And I think we're really there. But before I get to extolling all the virtues of electric power, I want to talk about some of the realities. And so on the screen, I've got here the typical ultralight engine, the Rotax 447, probably one of the most popular ultralight engines ever built in aviation. And Rotax builds an absolutely beautiful piece of equipment. But that motor on the left there is, well, with the electric starter and the B gearbox on that thing, it's about 93 pounds. I have on the right side just a random motor that I picked, the Nova 30, which also happens to be a 40 horsepower motor. And that 40 horsepower motor that you see on the right, instead of 93 pounds, that's 11 pounds. Now, 11 pounds, we need to add some more stuff to make this thing fly, but let's say we put a prop hub, a controller, a bunch of wires and stuff like that. Let's say we even end up at 20 pounds. That leaves us 73 pounds of batteries before we get to zero fuel weight. Now, if we were to take and put these on an equal footing where we could fly the same amount of flight time at exactly the same weight, we've kind of calculated out a round number of around 23 minutes of flight time on this thing. And so when you're talking 23 minutes of flight time, what you need to realize is that gasoline, the energy density in gasoline is so phenomenal that if we want to fly longer than 23 minutes, the gasoline-powered equipment just runs away with the efficiency on this stuff. There's no way we can even begin to compete. But if we want to fly less than 23 minutes, it now exponentially gets more favorable when we start talking about doing electric. That's the reason why the model airplane industry has gone bonkers with the electric airplanes, is simply because, we can fly for 10, 15 minutes and it's twice as efficient as doing gas-powered stuff anymore. And then all of the other reasons, which we'll get a chance to talk about. But that kind of puts some reality in the real world. If you want to do cross-country flying, just stick with a gas motor. That is really a great advantage. But one of the things that makes this so exciting is that, it wasn't that long ago when we were talking about flight times equitable to a gas power plant that were really in the neighborhood of 10 minutes. And now we're at 23 minutes. And if you look at the curve of where we're going with this stuff, it wasn't just, I think last month, one of the magazines, mentioned that we've now sold over 1 million electric vehicles in the world. And, those numbers just keep climbing every year. And as that happens, the energy density gets better, the cost goes down. All of this will just continue to improve as we get going. So the future is extremely bright for that very reason. But let's talk about a couple of other advantages that help us build into where we're going with this EMG-6. Cost of operation. Almost every operator has seen the writing on the wall here. We're really talking about, for the EMG-6, for a typical 1-hour flight, you're talking about a couple of bucks to pay for the electricity to fly that thing. We will eventually be into the spot where batteries are just, they're modular. You go fly for an hour, you come down, you put another one in there, and you go fly for another hour. Classic training scenario. It's going to be perfect scenario for the thing. So just the cost of operation starts to play into the picture a little bit more. How about if we talk about simplicity of an electric power plant? When we're talking about this little motor that I've got drawn in SolidWorks here up on the screen, this is one that's being built by a company in Southern California, and we're going to be doing all the testing on the EMG with this thing. But this is a motor that has one moving part on two bearings in the thing. Now, think about all of the thousands of parts that are in your typical engine today to make that thing run. When we're talking about one moving part, we're talking about exponential simplicity in terms of even a turbine engine. And so the size of these things makes them to be able to be modular. This motor that we have that's being built by R&D, we anticipate the TBO of this motor to be 10,000 hours. 10,000 hours of operating time before we have to overhaul it. Well, that's horrible, only 10,000 hours, and then we think, oh, well, what's the cost to overhaul this thing? We anticipate about $200 to do a complete overhaul on this motor. When you start talking about electric and you're comparing it with gas engine and you start talking about these kinds of numbers, you can't help but be excited about some of the possibilities. And the reliability and all of that other stuff. You know, you're not out there with a choke lever and you're priming the thing and you're pulling on the handle and you're jerking this thing on and off and on and off and trying to finally get this thing started, and then only after you get started you have this great big giant 15-minute warm-up time, and then you have to be real careful about shock cooling the thing. All of those things disappear in an electric power plant system. So just from the simplicity standpoint, the ability to take a little rheostat on your throttle switch and just run it right on up. When we were flying the first prototype, it was so fun. You just shut the motor off, and then at any point in time, you just crank the power up and whatever power setting you wanted. The motor didn't care. You just select whatever setting you want. Let's talk about regenerative power. Many of the power plant systems that are available have the ability to go into the regen mode. So like in a car, when you go to slow down, you're using the motors themselves to regenerate electricity and to act as brakes also. But imagine this scenario. We've gone out into the valley someplace. We found a place where we could take off. We launch and we fly 10, 15 minutes over to a ridge where there's awesome lift. And then once we're in this awesome lift and we've got all this excess lift, we can go into the regen mode and recharge the batteries while we're cruising this ridge. That now gives us, even if we're only carrying 23, 30 minutes worth of batteries, we'll just say as a standby, now we've got all kinds of options, especially as a glider. If we're out there and we just get cruising a little bit too far from home, we got 30 minutes worth of flight time to cruise on back. Or let's say that, we want to fly to a different site. We got 30 minutes to do that and then regenerate power off of the next ridge that we come to. All of these things are really going to change how we think about this electric power stuff. With that being said, let's talk about just a couple of the other things that we're going to see. These things aren't pipe dreams. These are things that are happening in real life right today. Prop indexing. With an electric power plant, you can select where you want the prop to stop. Horizontal, vertical, wherever it's going to produce the least amount of drag. Maybe you want it horizontal for landing so that if you're off-field landing, you don't get it stuck in the weeds or hit some bushes or something. There isn't any reason why we can't utilize maximum reverse thrust on these things. So now we have thrust reversers. How cool is that? The ability to go into thrust reverse on an airplane that takes 50 feet to land, and now we've got thrust reversers to even help with that. That's going to be pretty neat. Thrust vectoring. We're going to see, because of this whole new concept of having what we call distributive thrust, distributive power, where we can take small motors, multiple small motors, and we place them all over, and then we can control those independently from each other. The ability for many of these airplanes to change the position of the thrust momentarily for landing, for example. You're going to see tons of new airplanes that will be popping up where we're able to put the props into the normal cruise configuration, and then just before landing, we reposition them like a quadcopter, go full thrust for just a few seconds to make the landing, and that will totally change our short field takeoff and landing type aircraft. And so we're going to see more of that. We've already got on the drawing board a thrust vectoring version that fits two motors onto the EMG-6. Linear torque and horsepower. These linear torque and horsepower motors that we have, unlike a combustion engine, very specific torque and horsepower curves, and we really, in order to be able to take advantage of that, we really need to be right on those curves, everything working properly. With these type of airplanes, we can completely just select what kind of torque and horsepower we want, and if we need more, we'll just add more voltage to the thing, and we get more. As we go up in altitude, all of these gas-powered airplanes start running out of oomph. Well, electric motor doesn't need that oxygen except for cooling, and so now all of a sudden we've got some big advantages when we go to altitude. And of course, you'll see a lot of the high-altitude research airplanes all selecting electric power plant for that very reason. And even though you can say, oh, well, the prop's running out of efficiency as we go up in altitude. Well, that's true, but when we're not producing as much thrust, we're also not producing as much drag, we're not producing as much load. So what? Add more juice to the thing and just compensate for that thing. It's relatively a fairly simple way to go about doing that. So with all of this stuff that we're talking about, we just saw many, many applications where we could put this into the EMG-6, and including quiet operation. We've got so many of these airports that are constantly under threat from the public closing down these airports and, saying, oh, too much noise and restricted, flight patterns and stuff like that. Nobody would be complaining if these things were quiet. And in fact, if you're interested, Brian Seeley from the Cafe Foundation has this presentation he puts on dealing with pocket airports in downtown San Francisco. And the whole concept is, of course, based on being able to reduce traffic and congestion in downtown San Francisco and be able to fly to some small airport in an outlying area. But because of electric power, the ability to be able to do that without the noise really seems like a viable concept. So that kind of stuff can't do anything but make life better for everybody in aviation. So we saw that as a positive aspect also. So when we started down this path, we kind of had, well, you can see on the screen, I've got 9 basic design criteria that we picked for this. And of course, Part 103 ultralight was one of those that's really important to me. And then electric power, of course, was extremely important. Otherwise, I wouldn't have named it the Electric Motor Glider. And all of these other ones, number 6, I want you to look at real careful, because this has become a passion of mine, keeping the cost under control. And so with that being said, let's talk kind of about how this design got started and where we came from and a little bit of history behind some of this. The EMG-6 project was started back in 2012, and at the time, Quicksilver had just changed ownership, and the new owners of the Quicksilver company decided to become collaborators on this airplane project, and at the time they were building about 25% of the parts on the EMG-6. And I thought it was going to be a great collaboration, but in late 2014, Quicksilver announced their bankruptcy, basically called up and said, would you like to buy the company? And of course that wasn't in our budget or in our business plan at all. And so anyway, we were left hanging. It set the project back about 12 months and probably in the neighborhood of about $60,000. We've been, for the last couple of years, clearing all these hurdles to get back on track, and we're actually doing really good right now. Just before Oshkosh AirVenture 2016, we got the prototype number 2 flying, and we got a couple days of flying on it before we took off to AirVenture. And so this whole original design of Quicksilver, with utilizing the simple design that we have here on the screen, we were using a lot of the Quicksilver components because we simply didn't want to, why not utilize some of the technology they'd already developed. In fact, these wings are basically a modified Quicksilver GT400 wing. And we had sales and everything designed for all of this, and of course, when they went bankrupt, we lost access to all of the tooling, all of the templates for the wing sales, and basically, we had to restart thinking how we were going to do all of this stuff. But in the interim, we had the airplane flying, and so we started down doing a lot of testing with the basic design. And we have about 100 flights in the legal Part 103 configuration shown here. The airplane with the motor mounted in the thing, the first motor that we used, was about 226 pounds, and we just threw in batteries that would bring it up to the legal Part 103 254, and we had a BRS in the thing as well. And so we flew about 50 flights as a pure glider. We would tow this thing behind a vehicle with a ground tow operation. The airplane has both a ground tow and an aero tow release hook built into the airplane. One of the more fun things that we did was we towed it with a 400cc or a 500cc Honda four-wheeler, and that would tow great. I mean, it's just a hoot out there all day long. We'd launch. The only problem is all of my wing runners and my tow operators would get bored after about 10 flights and say, well, we've done enough testing. But great hoot to fly the thing. We then flew about 50 flights with the electric sustainer motor on the thing, which we're going to talk about in a little bit. And then we've flown almost 30 hours with the Polini 250 two-stroke engine, and we'll talk about that as well. And each one of the tests that we were doing was basically centered around flight testing for different configurations on the thing. And so we had a very strict flight test program during all of this stuff. And we ended up with very happy results on the prototype. We were extremely satisfied and enough to keep pressing on with the whole program. But just to give you a little bit of the performance specifications here, wingspan's about 37 feet. One of the criteria that we had is it had to be able to fit into a hangar without having to fold the wings or take the wings off like a conventional glider. It has about 170 square foot of wing area, and we've designed a 750-pound gross weight, which we'll talk a little bit more about. And as far as the performance characteristics of the airplane, the original prototype had a little bit slower wing on the airplane, and so we ended up with a best glide speed right around 40 miles an hour and a minimum sink at 35 miles an hour, and a V&E we've designed in at 90 miles an hour on the thing. And we typically like to tow the airplane when we're doing ground tow or aero tow in the neighborhood of 35 to 60 miles an hour. And 60 is about as fast as we've done so far. We may be able to bump those numbers up just a little bit more. Especially on the number 2 prototype. It's kind of a different animal entirely than the original ultralight version of the thing. So performance on the thing, on the original prototype, was very crude prototype design, but we had a glide ratio of about 13-1. That's about your average hang glider kind of glide ratio, and then a minimum sink of 280. And 280 is kind of the key number because of course, one of the best ways to reduce drag is go slower, and this airplane with its large wing area allows us to get into the minimum sink speed right at about 35 miles an hour, and the thing is just a floater. Launching to 600 feet on the runway and flying the traffic pattern, flying down over the high school and coming back around in for a landing and just doing that over and over again. Tons of fun just to be able to do those short flights like that. During the flight testing of the aircraft, we typically have 3 flight data recorders recording information of different types of stuff on each one of the flights. It helps us to build some real live data that we can then take and analyze. And this was off of the, I guess this is off of the variometer, but it shows us launching, climbing at about a little over 1,000 feet a minute, and then going into glide configuration. And then it shows a couple of spots where we're down to about 300-foot sink on the thing. And then this is a powered flight. And then later on in the flight, this isn't a very long flight, but we powered up. And you can see once we power up, we start climbing back up to 0. And then we're actually able, even with the little Predator 37, we were climbing for short periods of time at about 125 feet a minute. But that was we'll talk about the Predator 37 and what happened with that. Now, in the very early design stages of the airplane, we decided that we were not going to be motor, controller, battery management system developers, but rather we were going to build a platform that would allow all of this new technology to be modular on the aircraft so that we literally could, like in the slide you see here, this is the R&D motor. This fits into a socket, and one bolt holds it in place, and one bolt will remove the thing, and then we just have to disconnect the wires on the thing. And so we've got 3 motor mounts on the airplane, 2 on each wing, and 1 on the trailing edge on the fuselage there, that we can do different configurations. So you might imagine an airplane with 3 smaller motors, or maybe 2 medium-sized motors, or even 1 big motor like what we have here on the back of this thing. And that was kind of our design criteria right from the very beginning is that these motors and this technology, it's so fun to watch, but it's changing so rapidly. I mean, every week we're seeing some new stuff that's coming out. It's kind of like your cell phone. The minute that you've bought one, boy, there's a new model out there and you just can't wait to have that. So we wanted to make this stuff so that it would be modular. We'd be able to move it from one airplane to the next airplane and allow builders of the airplane to upgrade to newer technology as they had the availability. Now, originally, we decided we were going to make this, basically do a test on this Predator 37 motor. This power plant package that we have in the original prototype, everything is off-the-shelf model airplane stuff. The motor, the propeller blades, the controller, the batteries, the chargers, all of that, everything completely is off-the-shelf model airplane stuff that you can buy right today. We built a couple other things, like you can see the little cooling fan that's on the back and the little spinner. We built those in order to help with the cooling on the thing. But our original goal was just to use it as a sustainer and then do some evaluation on the motor to see what we thought about the whole thing. This actually is a 16 kilowatt. That's basically 20 horsepower at 6,300 RPM, spinning a 33-inch diameter propeller. This thing is small. The propeller blades, the propeller mounts, the motor mounts, the motor, the cooling fan, the spinner, all of that together weighs 5.3 pounds. Just absolutely incredible. And it puts out 100 pounds of static thrust on this. Well, 99.3, I think, is what the manufacturer says. We were never able to get that kind of control out of the thing, but we were getting some pretty good thrust out of the whole thing. We developed an entire battery mount system where we could simply take the Zippy 5000 model airplane batteries, cheapo Chinese-built Zippy 5000s. We built a little board to be able to safeguard each one of the battery cells so that they'd have a circuit protection built into the things. But we're just using them off the shelf, and we just stack these things, and we'd put them into what we would call modules, and each one of the modules could be stacked on top of the next module, and then we could select how many modules we want based on what we were going to do. And here was a basic configuration that we never did use, but this was one where with this many batteries in the back of the thing, we had computed, had we been able to use the power out of that electric motor, that this was about an hour's worth of flight time. And so we ended up using 4 of these modules for almost all of the flight tests that we did. And those flight tests involved, basically we'd go up, we'd run the thing until the motor would start overheating, and then we'd land. And with 4 battery packs, we could typically get about 4 launches out of those battery packs, and a total of almost 30 minutes. In fact, right at 30 minutes doing it that way. But all of the original flight tests that we did was based on doing ground tows to altitude. And so we would just basically tow. Sometimes we could get as high as about, I think 1,500 feet was about the highest we ever got. We just don't have a very big airport, and so we're kind of limited on space. But you can see in the picture there that little Honda 400cc or 500cc four-wheeler, and it'd tow that thing just great. In fact, it was really fun to tow behind it because it couldn't take off too fast. I'd drag it back down if it got going too fast. So anyway, we did a lot of ground tows with the thing. We had, like I said, over 100 tows on the aircraft so far on the original prototype, and we ended up developing the tow system that worked really well. It has a automatic release system built into the tow system, so if you accidentally overfly the tow rope, it automatically releases. It actually got to the point where the tows were so comfortable that once I was transitioned off the ground and positioned the airplane ready for climb, I could let go of the controls and fly it all the way to the apex before releasing without touching the stick at all. And so that was kind of fun. But the purpose of the ground tow was basically so we could get a little bit of altitude up there and then use the Predator 37 as a sustainer motor. And in this picture here, you can kind of see we're out there cruising around with the Predator on the thing. And we had some flights that were about 20 minutes long with the Predator 37. The downside of the Predator 37 is that we just eventually ended up not being able to cool the motor adequately. It's a great little motor for model airplanes and stuff like that, but it turns out that it probably wouldn't be my favorite choice to put onto the airplane. Would work well for some short flights. And so one of the first problems we had was we had the Schulz electronic speed controller shut down. And on this graph here, you can kind of see the red is indicating temperature on the thing. And the problem is that the Schulz controller has built-in protections so that you can't overheat the thing. And so when it reaches 100 C, it just shuts off. And right at about frame 1691 there, you can see the motor just shuts off. And on this one, we've got a video of this. We're just out there cruising around. We were fat, dumb, and happy, and it just shut off on us, so we had to land the thing. But it's a glider, so no big deal. But you can see kind of the following the throttle versus the RPM. Really good data, though, provided us a tremendous amount of information on the thing. And so right after we had this problem, we just decided, well, we just need a little bit more cooling on the ESC. So our next step was we went to Lowe's and we bought a CPU cooler. I think it was $97 for this CPU cooler. Machined out a little flat spot on the back of the ESC and just bolted that thing right to that. And that solved all of the cooling problem. The temps went way down. All the problems on temps on the ESC disappeared. And now the ESC was never a problem anymore. It was no longer in the picture in terms of limitations. The next problem was, of course, the motor. And we started identifying that we never did burn up a motor in air, but we could see that we were starting to get some temperatures. We had motor sensor temperatures that were just too high. And the problem was that the speeds that we needed to be able to maintain where we could use it as a sustainer motor, even in the, our plan was to put 2 on the wings. And even with 2 on the wings, the RPM that was necessary to be able to provide the thrust with that propeller anyway that we had just wasn't adequate. Even with 2 motors, we identified that it wasn't going to kind of work out. And so we went on to the next step of the testing on the thing. So that's what left the Predator 37 in the dust, where we decided that even though it's a viable option, it was kind of fun, to be able to, even at lower power settings, we would just use it, a little here and a little there, and we could keep it under control, but it wasn't, it wasn't where we're going. We need something that's going to be a commercial product, so we abandoned ship on that. Aerotow operations. We did a whole bunch of aerotow operations, and in this picture here, you can see Carol is flying the Quicksilver GT500, and she's towing me to altitude. And we've done, probably 50 tows total so far. Many of them, 3,000 feet gives us lots of time in the air with the airplane. And this is towing prototype number 2 right here. Prototype number 2 is so much less drag than the original prototype using the Quicksilver parts that we now easily tow to 3,000 feet before we cut loose. We haven't done a whole lot of higher altitude towing. We'll probably get to that in the not too distant future. One of the cool things is that all of these original transitioned ELSA airplanes have the operating limitations which allow us to use them for tow aircraft, not only for towing, but for commercial operations for tow. The new ELSA kits can't be used that way, but all of the SLSA airplanes can be used for tow. So anyway, we've also got a, and this is just an artist rendering here, but we've got a Varga Kachina, and the Varga Kachina has a tow hook on it that we put on also. It's a certified airplane. We plan on doing some testing with the new airplane with this, but we haven't used it yet. The problem is we've designed it for 60-mile-an-hour tow speeds, and that's kind of like stall speed for the Varga Kachina, so that could be a little bit entertaining for us. So we're still working on that little project, and we haven't got the balls to go do that yet. One of the next things we did with the original prototype, because now it just was a test bed for us, is we mounted the Polini 250 two-stroke onto this thing. And there's several videos of the airplane flying with the Polini 250 on the thing. It turned out to be a really awesome little power plant. This actually was originated from Tom Blankenheim there in Wisconsin. He wanted to build the EMG-6, but he initially wanted to have something where he could do some cross-country flying in the thing. And we've got a couple of flights now that are 2 hours in with the Polini 250 on the thing, and it works out great for that. But he bought the motor, and we decided that we would do all of the flight testing and develop the installation for that thing. So we initially just put it on the back of the airplane. Not our intention initially, but it would make it much easier to do the testing. We've gone through all the testing. We're totally happy with the motor. It's an awesome little power plant, 36 horsepower, and just really amazing. We did go through about 4 or 5 different prop combinations, and we ended up, in order to use that engine on this airplane, we ended up having to make our own propeller. And we have that capability in-house, and we're very, very happy with the final design propeller that we've got. And the next step is we're going to take this motor and we're going to move it to the back seat, and so that we can fare this all in order to be able to streamline the thing. The airplane, with all of this hanging out in the breeze with the big motor back there and all that, a little bit draggy, kind of flew like a traditional ultralight, just a little bit cleaner than a traditional ultralight, but we could really slow that Polini down and take advantage of its characteristics in cruise for some long cross countries if we can get that whole fuselage fared back in. So that's the next goal in terms of the Polini 250 on the thing. In this whole process, while we were doing all of this testing, we were also working on prototype number 2 to solve all the problems where we had been kind of abandoned by Quicksilver. And so we started working on prototype number 2. And at the same time, since we had this opportunity now, we started cleaning up everything and just changing the design. If we're going to go to all that trouble, why not clean the airplane up? And let me tell you, the new design's so much cleaner than the original. Almost triple the rate of climb on the toes using the new airplane. It just doesn't have any drag. Much of the time in flight, we are literally rope slack. In fact, on a couple occasions, it looks like I'm catching up with Carol when we're flying the thing. But we began the process of building prototype number 2, and we got that all finished up, and we were able to make it to Oshkosh, but only by robbing probably 25% of the parts off of prototype 1 in order to get this thing in the air just before we left. It also took us a lot of money and a lot of time. We had to accumulate a whole bunch of new machinery in order to be able to accomplish this. So we ended up with buying several new CNC machines. But now that we have all of that capability in-house, we have 5 CNC machines in-house that we can do different types of manufacturing with. These are some parts that are for the wing fold mechanism on the airplane. And it's just nice to be able to do all that stuff in-house right now. So we've made good progress. Right before Oshkosh, we finished up the prototype and had it ready to put in the trailer. We literally ended up getting 2 test flights on the airplane, 2 days of test flying on the airplane. The first day we did half dozen or so ground tows. Everything was looking awesome. So the second day we continued the flight testing with ground tows, and then we immediately did about a half dozen aero tows to 3,000 feet. And this is the picture of us flight testing without the motor on the thing, just as a pure glider. You can see Carol is flying off into the sunset out there. She's flying so we can get her in the picture also. But everything went awesome. The next day, this airplane was tore down, put in the trailer, and we headed to Oshkosh. It just literally was that fast to make all of this stuff happen. So the next electric motor that we're going to test, we have in-house now. It's not completed yet, but R&D is a company in Southern California. They're actually an electrical aerospace company that does electrical cables, but they've got a whole bunch of really sharp people down there, and they decided to build this motor. And we actually became friends with them during one of our 120-hour courses, and they just took this on as a side project. But they've got some pretty sharp people, and they're actually right now about 96% efficiency on the motor. It's designed to be able to operate continuously at 20 horsepower. It's only a 24-volt system. They wanted to be able to make it redundant and safe, and so they selected 24 volts. But they'll run it on the test stand, and even after 30 minutes of run on the test stand, it's so cool that you can physically put your hand on the outside of the motor after 20 minutes at full power, under load, under torque on the test stand. So we're kind of excited about it. They've lost their lead engineer, so we're waiting for them kind of to get up and swinging again on this thing. The lead engineer on this project transferred to a new job, and so they've been kind of hamstrung in that area. So that's the next one that we're planning on testing. We've got other things in the works, though. But I want to talk to you about what I see as just the total game changer for everybody. You know, it was when Paul originally formed the EAA, the aircraft were being built with, you know, Volkswagen engines and McCulloughs and all of this military surplus stuff. And, you know, we were getting this existing technology. It's very hard to, with the numbers that we have in the experimental world, it's very hard for any manufacturer to really make a big, giant dent when it comes to making a product. And that's normally the reason why the products for aviation are so expensive. We just don't sell the numbers. But think about this for a second. We've just hit the $1 million or the 1 million vehicles sold in the world, electric vehicles sold in the world. And those things are crashing at a pretty alarming rate. It's not alarming, it's spectacular, because all of that stuff now becomes available in the junkyard, and we can go buy that stuff. And I just talked to a couple of guys the other day that had just recently bought a Nissan Leaf. It was all mangled, but all of the electrical components on the entire Nissan Leaf were intact, and they paid $2,000 for that thing. Now, the batteries alone in a Nissan Leaf are worth about $10,000. So when you start thinking about, oh man, we're just going to be able to go leverage all of this junkyard stuff that's going to be perfect for us, you know, controllers, battery management systems. The batteries themselves, we'll pull the batteries out and, you know, reconfigure them for an airplane. I think, you know, for the EMG-6, I think you could equip batteries for 4 airplanes out of one Nissan Leaf on the thing. So we're really excited about a lot of that kind of stuff that's going on, and we think that that's where we're going to just see some tremendous, you know, there isn't hardly a car manufacturer today that isn't building an electric vehicle. They're not doing this for entertainment. They see the writing on the wall. They know where this is leading. They know what's going to happen in the future. These guys are smart. You wait and see. Now, this next one is kind of my new love right now. The new 2016 Zero FXS, I think I can say that, is pretty awesome. They've got 2 power plant options available. One is a 27 horsepower, and the other one is a 44 horsepower. Now, both of these motor configurations are awesome for the EMG-6. We're just really excited about trying either one of these 2 configurations. Mark Byerly with the Eagle has already done this. He's done it on a little different motorcycle than these with, I think, I think he's about a 60 horsepower configuration. He ended up swinging a pretty big propeller in order to be able to get the thrust that he needed on that, and he makes his own little reduction drive unit for the thing. But we've always been really excited about the possibility of not having to do that complexity and that cost and that reliability issue of using reduction drive units. And it just happens that both of these motors are designed for 3,700 RPM max RPM. And with our 50-inch propeller, that's absolutely right exactly in the ballpark where we want to be for this thing. So we think we can use these motors direct drive. We haven't seen the motor yet. We don't know exactly how it's going to work, but Mark has kind of blazed the trail for us already and proven the reliability. He literally takes the batteries, the motor, the controller, the charging system, the dashboard right out of the motorcycle and just retrofits them directly into his airplane. And so that's pretty exciting. The cost with government incentives on electric vehicles on this motorcycle right here, brand new out the door, $6,895. Now, even if you bought the entire motorcycle and yanked that out of there, that's not a bad cost just to go around doing that. But when we start talking about junkyards and crashes and mangled up stuff, or even buying a new motorcycle, take advantage of the subsidies, steal all the good stuff, and then sell the rest of the brand new motorcycle on eBay for spare parts, you probably are talking pretty cheap way to go. There's a bunch of other manufacturers out there that are also doing exactly the same thing, and we're seeing more and more electric motorcycles all the time. we're going to have some options in the not too distant future that are just going to be awesome for the electric world. So we're looking forward to that. Now, remember in the beginning I said, one of my exciting areas that I'm really excited about is the cost. And so we are doing everything we can in order to be able to get the cost of these kits down. And we're basically, if you're a welder and you're going to build your own stuff, you can buy the basic kits for this thing, and we think you'll be right in the ballpark of $10,000 to $12,000 for the cost of one of these airplanes if you're a welder. We have gone to the steps now of making all of the plans available online for free. You can go to our website, go to the Builders Database, download all the PDFs you want. We're going to eventually get some money out of you, but we believe in this whole process. We would like you to be able to take the time to go look at all of the drawings. We continually add to them. We continually upgrade the things. They're all designed on A-sides drawings. They're designed so that you can print them on your home printer. You're not going to have to go do a whole bunch of weirdo stuff in order to be able to do that. They're all designed so that you can use them on an iPad or some other laptop device kind of thing. We have a lot of builders that simply take their iPad right directly out to the workshop and they work right off of that. In addition to that, we've provided a whole bunch of other kinds of files on the website for free also. Because this is designed in SolidWorks, there are many, many e-drawings, and you can download a free copy of the e-drawings viewer and simply grab the part and start rotating this thing around. You've seen how we operate and manipulate 3D drawings. You can zoom in, look at something, cross-section it. It's just amazing what you can do. All of those are on the website as well for free. This airplane has a 4130 steel cage on the thing. It's very user-friendly. It's one of the most complex parts on the airplane, and so that's one of the areas where we wanted to be able to provide you the ability to build that yourself so that you could reduce the labor costs in order to make that stuff. We have provided not only all of the drawings to be able to do this, but we really have come up with a super trick system for cutting all of the tubes on the airplane. And we have this template system where, if you haven't seen how to do this, we've got a couple videos on it that you can go watch. But we simply print this on your printer at home. You cut it out with an X-Acto knife. You wrap it around the tube. You slide it to one end. You mark the end. You slide it to the other end, mark the end. And there's some marks for interim marks as well. And it's like having CNC cut tubing when you go to fit all this stuff up together. If you're a welder, you will appreciate this tube marking stuff rather than cut and fit and then weld up the 3/4 inch gap that you just made. This is just phenomenal. It's exactly the same system we use in the shop to create the frames. We're not doing it any different than the builders are doing this. Now, not only are we making all these templates in-house, we're building the fixtures in-house so that we have DXF files. You can literally either rent the jigs for these things, or you can download the DXF files, take them to the local cabinet shop, and cut all these things out on MDF plywood or 3/4 inch plywood or MDF and make your own jigs if you want to. Our goal is not to do that, but rather to rent out the jigs, and so that's kind of how we've been pushing this whole system. Borrow the jigs for a little while, basically $50 a month with a $500 deposit, and then when it moves to the next person, you get your deposit back. Usually will only take you about 2 months is what it took Charlie to put his frame together, and then he moved the frames down to the next builder. And so all of these parts, they all come boxed up and pre-manufactured. When you're building the parts on the airplane, you're using exactly the same jigs that we use in the shop to be able to create the thing. And so it'll show up in a box kind of like this where all of the fixtures fit in there. It's basically 4 pieces of 4x8 sheets of plywood in order to make all the fixtures. Ed Santucci in North Carolina is one of our builders, and he has been taking the drawings and he's just making his own fixtures that are much simpler. He obviously knows what he's doing, and he's been adapting that, and we've agreed that we'll supply him with any dimensions that he needs in order to be able to succeed at this whole process. The fuselage boom is a 2024 T3 aluminum fuselage boom. And so we've created all of those parts, our CNC match drilled, basically Cleco and pop rivet together. Takes the average, well, it takes Jason in our shop. He's got it down. He's been building them. He does about 4 hours, and he's finished with that sucker now. He's getting pretty good on it. But all of that, even if builders wanted to build these parts themselves, like the bulkheads, we've got drawings where you can do that. But the whole goal is, of course, on something like this where we've got match drilled parts, why not just throw them up on the CNC router, and we cut the parts out and then bend them up ahead of time so that everything fits perfectly. And that's kind of how we've been doing that. In addition to the sheet metal parts, we've been outsourcing all of the metal parts with laser cutting. But oh my God, the cost they get for laser cutting these things is ridiculous. So we're still cutting a lot of them in-house with our mill. Kind of a harsh way to do this. Boy, this laser cutting is pretty awesome stuff. So anyway, we are also trying to build the airplane with as simple, low cost as we possibly can. So, for example, the wing struts are the basic original Quicksilver 1-inch 058 6061 T6 aluminum tubes, and that's how we flew the prototype. And then once we did that, we just retrofitted them with a wooden trailing edge, covered them with fabric, and we increased the performance. And then if you want to go the next step up, we've got these 6061 T6 aluminum extrusions that we've made that retrofit directly. So you can start off with the basic stuff and then upgrade stuff as we go. We want the airplane to be simple, but we want to allow those that want to be able to make this thing more high-tech. That's why we did all of the enclosures and all of that kind of stuff later on. Wing fold and tail fold. The airplane was originally designed because people need to be able to fold this up and put it in a trailer, so we've designed that into the airplane. The original prototype folded up pretty cleanly. We were able to get it into the studio at EAA for one of the Hints for Home Builders sections that we were doing because it folds up. It's actually only 33 inches wide in the completely folded position. This, of course, with the mono wheel and the training wheels to keep it from tipping over. The new prototype number 2, we still got a couple of bugs on the wing fold, but we're working those out as we go. The whole idea, of course, is that we want the airplane to be trailerable. That's a big feature for a lot of people. So we've been working that into the plans right from the very beginning. The airplane is a 2-place airplane, but let's talk reality here. You know, this is not your typical 2-place airplane. But it has a gross weight of 750 pounds. The original ultralight weighed in at 200 pounds, a little over 200 pounds. That leaves us a substantial amount of weight. So we could put a couple of pilots in there and still be under the 750 pounds. The whole goal there is, of course, that, we need to be able to do some transition training. Maybe we want to fly the thing around as a pure glider and we've got access to either ground tow or aero tow. It'd be a great way to do some basic training for people that are not familiar with the airplane. If you're going to fly it as a powered airplane, let's say you put a little 2-stroke in the thing, probably with 750 pounds, you're going to be restricted to basically a single-place airplane at that point. Or maybe a smaller electric sustainer motor and a smaller passenger. But 2 fat guys like me, we're going to be a pure glider in those kind of configurations. But the whole goal here is to be able to provide options, be able to provide different types of configurations depending on what your mission is going to be for the airplane. So build it lighter, keep it simple, and you can throw more goodies onto the thing. The airplane was designed right from the very beginning with the capability of putting a Brs parachute in it. And, of course, during all of the flight testing, we have a Brs parachute in there. But it is certainly an option. We don't think... I hate putting that extra weight into the thing. I can't imagine why anyone would want all that extra weight on board the airplane. But kind of a necessity during all the flight tests because we're really pushing the envelope in some of our tests. We have multiple landing gear configurations. The mono wheel, I've flown 100 flights with the mono wheel configuration. I flew 3 flights with the training wheels, and you can see the training wheels mounted on here. It's actually takes about 30 seconds to pull the wheels on and off. They're just pit pins, and they just kind of like a trike when you were a kid. You know, you're a toddler and you're learning to fly. Put the training wheels on there, and then the airplane will stay right side up while you're flying the thing. And as you get better and better, you can shrink up the struts on the training wheels and operate it more and more like a tricycle. But I only had it on there for 3 flights. I didn't think it was necessary, and so the other 97 flights were without training wheels, and I've never drug a wingtip yet, even though you can see the wingtip wheels that are built into the wing. I took those off eventually too, just because I didn't like the drag of the wheels on the wingtips out there. But with a little bit of practice, if you're a glider guy flying with one wheel, and remember, we're landing literally a lot of the landing speeds. There's a couple videos you can see online, about 30 feet landing distances with a little headwind. Most of the flights, we just come to a stop, we hold the brake on, and we put our foot down and then hold the airplane up. You're just kind of straddling the airplane. Very easy to operate. We've built the tail wheel configuration with a steerable tail wheel, the conventional gear. We even have on the drawings the nose wheel version of the thing. That's kind of ridiculous, but we may do that at some point in time. The next one I'm excited about is I want to fly it with skids. Take that stupid big fat draggy wheel out of the center and just put a couple of little skids like like on a helicopter, the skids on a Bell helicopter. This thing literally lands in 50 feet with no wind. What are you so worried about? Land on the grass, and you'll probably be 20 feet landing on the thing. So I'm excited about trying that one fairly soon. But lots of different options on different ways to go with the landing gear. A lot of people need that extra stability and want that stability, and got tons of videos on flying it with the tail wheel configurations. So the whole concept has just been a total blast. We get out there and fly like this, even without running the motor, just launching one after the other, absolute hoot to stay up in the air. And of course, the whole goal is to be able to fly long distances eventually, but our primary whole thing that we're doing is, develop this airplane so that, we can adapt to the new technology that's coming out as people build these new motors and stuff like that. And we're gonna see so many people develop so much neat stuff in the future. It's just going to be amazing. But back to this way that we're flying the airplane right now. As a sustainer motor only, even with, say, 15 to 30 minutes worth of power, remember, most of the time, a glider, you're going to be out there cruising around, and you're going to be catching thermals or flying ridge lift or something like that. But just to have a little bit of power to do things like, do a go-around, for example. That'd be kind of cool if someone pulls out in front of the runway on you. That's not really an option in the glider most of the time. Backup glide path control. Maybe you're a little short. Oh, that'd be nice to just have a little bit extra power we could add to the thing in order to be able to get to the runway. Just that kind of stuff. We can now, with sustainer capability, we can go out and we can fly, further than where we would normally because it's too far to get back to the airport. But, if we get all hosed up and we run out of lift and we're in sync, just crank up the motor and start flying on back to where we should be. So tons of options that we're going to have in that area. So I see that I am running out of my time here. What time is it now? It's I think we're 6 o'clock. I don't know how long. I don't know if you're there, Charlie, but I don't know how long I'm. Yeah. So I'll put this last slide up here and just talk about it a little bit before we get into questions and answers. But the electricmotorglider.com is the website. And then there's several emails, but you can just use adventureaircraft@gmail.com, and that'll get sent to us, as well as several other contact email addresses that are on the website. A couple of things I want you to do. On the website, it says follow by email. Go click on that, throw in your email address. We're not very sophisticated around here. I got no time for doing anything other than work on this airplane. We're not spamming you. We're not smart enough to spam you, and we don't have the tolerance for doing that kind of stuff anyway. But you'll end up with, we just get a ton of feedback about people liking this, because anytime that we make an update to the website, it automatically sends out a blurb of whatever the newest post was to your email address. And I get a lot of feedback on people really liking that. And then they only come back to the website every couple of weeks or so to check to see what they've missed. There's tons of stuff on the website for research. I just recently realized that the index has not been working for quite some time. I don't actually know how long, but we've got that working back up on there. I don't know, but I think there's close to 200 posts that are on this about different subjects, and we keep throwing in new information on a regular basis. Also, I want to point out the the link to the YouTube channel. We do a lot of other stuff other than the EMG on our YouTube channel. We do a lot of stuff on, other airplane stuff. And so there's other stuff there. But I want to encourage you to go there and subscribe to that. I try and only put out high-quality information. Recently, we've been flooding the website with a project where we're doing a bunch of SolidWorks stuff. And so you can just ignore that if you're not into that kind of stuff. But we'll eventually develop that into a neat little package that we're going to put together for people watching how to do some SolidWorks stuff. But please go to YouTube and subscribe to our channel there. I watch that stuff every day. I'm like all excited when somebody signs up for the thing. We're about 750 subscribers on that now, and it keeps growing. So we're pretty excited about that. So I think I've babbled long enough here. I think probably in order to give everybody a chance, we can start doing some questions if you've got some there, Charlie.